Find the derivative of y squared over x squared plus y equals 5x cubed minus 4y minus 11. We have an implicit equation here. We have an equation involving x and y, but it is not solved for y in terms of x, and it's not possible to solve for y in terms of x, at least not in a simple fashion. So we will take the derivative implicitly. This is done by taking the derivative of both sides with respect to x. I will indicate this by a prime on both sides. On the left side, we have a quotient rule. The derivative of the numerator, 2y, and then times the derivative of y prime to complete the chain rule. Every time we take the derivative of a y term, we will have a y prime multiplying it to complete the chain rule. Derivative of the numerator times the denominator left alone minus the numerator left alone times the derivative of the denominator, 2x plus 1 y prime, or just simply y prime. We just took the derivative of a y term. Again, we get a y prime. And then that entire thing divided by the denominator squared equals to the derivative of the first term, which is a power rule, minus 4 times the derivative of y, which is y prime. In the next step, I'm going to take this denominator produced from the quotient rule and multiply it to the numerator, in which it will then distribute. So we have 2y, y prime, times x squared plus y, minus y squared times 2x plus y prime, the entire numerator, equals to multiplying the denominator over x squared plus y quantity squared, which will distribute into 15x squared minus 4y prime. In the next step, let's distribute this into here. The first term, we have a 2, we have an x squared, and we have a y. I will write the x squared first before the y, and then a y prime at the very last. Plus, we have, for the next term, a 2, a y, and another y squared, and then a y prime at the last. Now let's distribute the negative y squared in here. Distributing the negative y squared in, we'll have a negative 2 and x, and then I will put the y squared after. And then I have a negative y squared times y prime for the second term after distributing it. Equals to, on the right side, I'm going to distribute the x squared plus y quantity squared in, and that will give us 15x squared multiplying times x squared plus y squared, and then a minus 4y prime times the x squared plus y squared. I have a total of 4 terms that have a y prime. I have this one, this one, this one, and this one. I'm going to move them all to one side to isolate them. I'll put them all on the left side. And then I have 2 terms that are not circled that do not have a y prime, and I will move those together on the right side. So I will have 2x squared y prime. The next 2 terms, I have a 2y squared y prime and a minus y squared y prime. Those can actually combine. 2y squared minus 1y squared is 1y squared times that y prime they each have. And then I'm moving over by adding over the y prime term that was on the right. And this will equal to, and I'm moving over the one term that does not have a y prime on the left, the negative 2xy squared, added over to the other side. We can now factor the y prime out. Leave the right side the way it is. And we can now divide both sides by what's in the parentheses on the left side to solve for y prime. And that comes out to 2x y squared plus 15 x squared times x squared plus y quantity squared divided by 2x squared y plus y squared plus 4 times x squared plus y quantity squared. There's no common factors in the numerator or denominator that we'll be able to cancel once we factor them out. So that is the simplified version of the derivative y prime.